An Embraer ERJ-190 belonging to Kazakh flag carrier Air Astana took off from Lisbon. It seemed like a routine flight, but soon the pilots found themselves thrown into a nightmarish emergency unlike anything. Their plane had become uncontrollable, rolling wildly in seemingly random directions, turning inverted, diving towards the ground at tremendous speed, only to pull out and start the same roller coaster ride all over again. Faced with a near-certain catastrophe, the pilots made a chilling request. But before we could unravel the mystery, we need a backstory about Air Astana. It had an unusual birth. In 2003, Kazakhstan decided to try a new approach, partnering with British defense contractor BAE Systems to start a new airline under new management. Air Astana had positioned itself as Kazakhstan's de facto flag carrier by 2005. It's also among the safest. It has never had a fatal accident, and for the first 13 years of its existence, it was the only Kazakh airline allowed to fly to the European Union. Between 2011 and 2020, Air Astana operated 9 Brazilian-made Embraer E190 regional jets, capable of carrying up to 97 passengers on shorter domestic routes. Air Astana does not have a repair shop capable of carrying out heavy maintenance on Embraer jets, and neither does any other company in Kazakhstan. It should be mentioned that the ERJ series has been proven safe and has passed all the international aviation tests required by different countries to operate airplanes in their airspace. Now let's come back to our main topic. In the fall of 2018, one of Air Astana's E190s, known as P4KCJ, registered in the Dutch Caribbean island of Aruba for tax purposes, came due for a scheduled C-check, a round of heavy maintenance and inspections which every airplane must undergo approximately once a year. For this purpose, Air Astana had in place a long-term contract with an established Portuguese maintenance company called OGMA Indústria de Portugal SA, or OGMA for short, which possessed European Aviation Safety Agency approval to perform heavy maintenance and inspections on Embraer aircraft. Captain Aushev, First Officer Karashalikov, and First Officer Sokolov were to pilot the airplane from Lisbon to Minsk and then finally to Almaty, Kazakhstan. On November 11th, sometime after noon, Air Astana Flight 1388 was ready to depart. Unaware that their aircraft was dangerously unairworthy, the pilots taxied to the runway and took off normally at 13:31 hours, climbing away into the dense rain clouds that blanketed the airport. They had no idea that they were about to be thrust into one of the most dramatic and lengthy in-flight emergencies in recent memory. For about 10 seconds after takeoff, everything seemed to be normal. But then, slowly at first but growing in amplitude, the plane began to sway from side to side. As they ascended into the cloud layer, the pilots tried to correct this swaying with the ailerons and rudder, but the oscillations kept increasing. Something was wrong, but what? There were no warning lights, no failure message on the ICAS, and no sign of any malfunction. Captain Aushev tried to engage the autopilot, but it failed to activate, throwing out an error message. Within 2 minutes, the situation had escalated into a full-blown emergency. The plane started to roll to the left, and this time, they couldn't bring it level. Shuddering violently, the plane turned over into an extreme left bank, causing the wings to lose lift. The nose fell through and the plane began to descend. In a matter of seconds, it plunged 1,000 feet before the wings rolled level and Captain Aushev was able to pull out of the dive. To get some cushion, the pilots tried to gain altitude as much as possible, but gaining altitude proved to be a nerve-wracking experience. The plane couldn't be controlled in terms of roll, often tipping into steep bank angles and quickly losing altitude. If Captain Aushev tried to lift the nose while the plane was sideways, it could lead to an irreversible spiral dive. He had to wait for the plane to level out on its own before pulling up abruptly, aiming to gain as much altitude as possible before it happened again. The timing of these reversals was initially unpredictable due to varying airspeed and flap settings in the fly-by-wire system's normal mode, making it hard for the pilots to manage the plane. After a few minutes, the pilots switched to direct mode, which removed computer control and stabilized the deadband at 5.5 degrees of control wheel movement in either direction. Despite this, the pilots struggled to understand the plane's behavior, especially since they lacked outside visual references and had to rely solely on their instruments. As the pilots struggled to understand the plane's completely unpredictable responses to their inputs, Flight 1388 embarked on a roller coaster trajectory that simply refused to end. After initially climbing to about 10,000 feet, at 13:38 hours, the plane suddenly rolled over into an extreme dive, plunging 5,000 feet in a matter of moments. The descent rate briefly reached 20,000 feet per minute, and the occupants were subjected to a bone-crushing 5 Gs during the recovery, approaching the ultimate structural limits of the aircraft. The pilots were lucky that the E-190 was bendy enough to take it because they came alarmingly close to ripping the wings off. Following this terrifying dive, the plane oscillated wildly between 5,000 and 7,000 feet for several minutes. Nevertheless, by 13:45 hours, the pilots managed to get it back above 10,000 feet.
Flying 1388, we have flight control problem. Flight control capability declining 10,000 feet back finish 1010 on present heading.
Only to dive again, losing around 4,000 feet and pulling 3.5 Gs, again exceeding the design limit load. But still, the plane held together and the pilots put it back into a climb, struggling back up to about 16,000 feet with only one relatively minor altitude loss along the way. This picture shows the flight data obtained from the airplane. At 14:03 hours, the flight faced a severe issue. The plane flipped upside down and entered an inverted dive, falling toward the Portuguese countryside at more than 20,000 feet per minute. The plane shook violently, and the altimeters dropped too fast for the pilots to read. The airspeed approached 350 knots, and the ground proximity warning system began to scream.
Pull up! Pull up!
The pilots complied, but if they pulled up too forcefully, they would overstress the airframe and the jet would break apart in midair, while if they did so too slowly, they would strike the ground. The pilots struck a delicate balance and succeeded. After losing over 10,000 feet in less than a minute, Flight 1388 began to level off. Shaken by the sudden plunge, the pilots understood that they were flying on borrowed time. Sooner or later, their luck would surely run out. Fearing that they could crash at any moment, their thoughts turned to people on the ground. Now, over the Lisbon ATC frequency, they made an extraordinary request that they be given a heading over the ocean to ditch at sea, where they would be less likely to kill innocent bystanders if they lost control again.
1388 requesting heading for ditching. Mayday, we need a vectoring to the sea, to the ditching, please. Away from the street.
1388 flying heading 260.
The Lisbon air traffic controller tried directing them towards the ocean multiple times, but the pilots couldn't comply with their instructions.
260 river, okay. Maybe ocean? No, so far?
The ocean is 40 miles from your position, sir.
Captain Aushev later joked that the plane could only maintain a steady heading for about 1 second, meaning it couldn't hold a course at all. The flight map shows the plane's flight path. As the plane kept moving erratically, the pilots tried different solutions. They thought about disconnecting the control wheels but decided against it because both pilots needed to steer. Using both helped roll the plane in the right direction by deploying the roll spoilers. They also switched between normal and direct mode on the flight controls, but it didn't help, so they stayed in direct mode. According to the pilot's account of events, it was at around this point that they got the bright idea to contact the 3 Air Astana technicians in the cabin to see if they knew anything about what exactly had been done to the plane during the sea check. This proved to be the silver bullet which ultimately saved their lives. As it turned out, the technicians had with them the comprehensive paperwork describing everything that had been done, and at the pilot's direction, they began to look through it until they found the smoking gun, an entry in the log that said, "Aileron cables changed." The pilot suspected that the ailerons might have been connected incorrectly, which would explain the erratic behavior. To test this theory, they asked technicians to observe the aileron and roll spoilers movements from the passenger cabin as they made different inputs. This task proved challenging because the cockpit door kept closing on its own when the plane rolled left, and one of the technicians was violently thrown against the wall while trying to open it again, spraining his ankle. Despite these challenges, the technicians confirmed the pilot's suspicion. The ailerons were moving opposite to their commands, although the roll spoilers worked as expected. Once the pilots understood the problem, they adjusted their inputs to maintain control of the flight. This turning point occurred around 14:38 hours, when the flight parameters became noticeably steadier. Around this time, the plane also exited the cloud cover and entered clear conditions, giving the pilots better visibility and orientation. By this point, They had been careening around central Portugal for over an hour, and the pilots had little idea of where they were or where they were going. The controller suggested that they land at Beja Air Base, a military airfield close to their position with good weather and a long runway.
Kilo Zulu Romeo, this is Portuguese Air Defense. How do you live?
I read your phone now.
Copy. We are 60 miles north of your position. We will try to intercept you and give you any assistance required. How can we assist you?
We have now flight control problem. We need airport with good weather. With feeling okay. You have aerodrome with good weather.
Kilo Zulu Romeo. Are you now able to maintain an heading and an altitude?
Yes, sir.
Okay, copy all. If you wish, we can intercept you and guide you to the aerodrome for you to land safely.
Okay, yes.
Despite that, the pilot still insisted on ditching the plane to save others from collateral damage. To help them find it, 2 F-16s of the Portuguese Air Force were sent to intercept the plane, reaching it sometime after 1445 hours. Under direction from the F-16s, the pilots were able to maneuver the plane onto a straight-in approach to runway 19R at Beja Air Base. But as they approached the airport, the plane once again began swaying from side to side, its course wobbling like a fishtailing trailer on the highway. Most likely, the pilots were unconsciously reverting to normal roll inputs during the high-stress approach, causing the plane to turn off course repeatedly. Although it took them some time to realize this, it was clear, however, that they would not be able to land in this condition. So as the plane approached the threshold, Captain Auschev called for a go-around, and Flight 1388 climbed away for a second attempt. First Officer Karashalikov's journey ended here. The youngest and least experienced crew member, he had been deeply shaken by the flight and felt too ill to continue as co-pilot. Captain Auschev recognized Karashalikov's incapacity and agreed to let him switch places with safety pilot Sokolov, who then took over the right seat for the second approach. Despite Sokolov's help, however, the second approach failed for the same reason as the first. As they climbed away once again, Captain Auschev decided to lay down the law. This time, no one was going to touch the ailerons at all, and they would steer using the rudder only. At first, this technique seemed to be working, and the third approach appeared to be on track to succeed. But at the last moment, the plane started to veer to the left, drifting away from the runway and heading less than a minute from landing. Thinking quickly, Auschev announced a change of plans. It would simply land on the parallel runway 19L instead of runway 19R. Moments from touchdown, the pilots managed to straighten out in line with runway 19L, and just like that, victory was upon them. At 1527 hours, Flight 1388 touched down with a shudder of joy, and although the plane almost veered off the left side of the runway, crushing several edge lights in the process, the pilots managed to keep it under control. Finally, after nearly 2 hours in the air, P-4 KCJ came to a stop right side up and in one piece. Despite great adversity, they had beaten the odds. In the clip of the landing, we can see that the plane was swaying extremely, further showing how difficult the landing was only with the help of rudders. By the time Flight 1388 landed, investigators from Portugal's Office for the Investigation and Prevention of Accidents in Civil Aviation and Rail, or GPI-AAF, were already heading to Beja. The agency had been alerted while the plane was still airborne, during a period when it seemed likely to crash. Though relieved that the plane landed safely, investigators understood that the outcome could have been catastrophic, warranting a thorough investigation. Upon inspecting the airplane, they found how close it had come to disaster. After repeatedly exceeding the design limit load, the wings, skin panels, and fuselage structure had been permanently warped. The skin was wavy in many spots, and the wings were bent upwards toward the tips. The extensive damage meant the plane was declared a total loss and never flew again. In the image shown, we can see the extensive damage to the plane. As for the crew, they were damaged in their way. In addition to the sprained ankle suffered by one of the technicians, several occupants were treated for acute nausea induced by the plane's wild maneuvering, including First Officer Karasholikov, who was the worst affected. In addition, all 3 pilots were affected psychologically by the period of prolonged stress in the face of near-certain death, and all were granted indefinite leave until they felt comfortable returning to the cockpit, which all 3 eventually did. We want to take a moment to appreciate the brilliant efforts of the pilots. How they controlled an uncontrollable plane is a miracle in itself, And despite the airplane's issue, it's commendable how structurally sound commercial planes have gotten with the ability to withstand multiple Gs without structural loss. However, it should be mentioned that the plane was empty and it helped its structure in these dire situations. On a full flight, the results might have been devastating. Just before we dive deep into the investigation, you need to know the very basics about how a plane steers and lifts, so that you can understand the terminologies better. A plane steers and lifts using its wings and control surfaces. The wings create lift by having a curved shape, which causes air to move faster over the top, creating lower pressure, and slower under the bottom, creating higher pressure. This pressure difference lifts the plane. A plane steers with ailerons, rudder, and elevators. Ailerons are flaps on the back of the wings that tilt the plane left or right. They work by moving in opposite directions, with one aileron going up and the other going down. This causes the plane to roll. The rudder is a flap on the back of the tail that steers the plane left or right by changing the direction of the nose. Elevators, also located on the tail, control the pitch of the plane, allowing it to go up or down. Some planes use a system called fly-by-wire. In fly-by-wire planes, the pilot's controls are linked to the control surfaces by electronic signals instead of mechanical linkages. The system uses computers to interpret the pilot's inputs and adjust the controls, making flying smoother and more efficient. Now let's get back to our investigation. In Beja, one of the first things investigators examined was the aileron control cables. They discovered that the up and down cables in both wings had been reversed near where recent maintenance work had added non-contact structural supports. Although further testing and simulations were conducted later, it was clear that this was the main reason for the pilot's struggles. In this picture, the color coding was added after the investigation. It's easy to see how technicians could have been confused. The GPI-AAF concluded that OGMA technicians had mistakenly installed the cables backward while following confusing instructions in Embraer's maintenance manual. This error was hard to catch for three main reasons. First, the cable's relative orientation changed unusually near the mistake, making it difficult for an independent inspector to see that the cables were crossed. Second, during operational tests, the synoptic page indicated the controls in green, showing that conditions had been met but not necessarily that the test had passed a point made clear in the flight operations manual but not in the maintenance manual. Lastly, the technicians lacked the aeronautical knowledge to know how the ailerons and spoilers should move, and while the maintenance manual explained this, they didn't seem to fully understand the relevant section. Moreover, the fact that this lack of knowledge was so widespread led investigators to conclude that the problem likely began on an organizational level. Although OGMA had been around for many years, it had recently begun to suffer from excessive staff turnover, resulting in a hemorrhaging of institutional experience. The lack of effective competency testing to assess technicians' knowledge made the problem worse. The GPI-AAF also criticized OGMA for poor record keeping, finding inconsistencies in inspection paperwork and work cards, showing a lack of strict adherence to procedures. Following the incident, all involved parties took safety measures. Air Astana increased its supervision of maintenance contractors and introduced special procedures for pilots on maintenance acceptance flights, providing them with information on worked-on systems. They also revised standard operating procedures to have pilots verify control surface movement before pre-flight checks. Embraer enhanced the quality of its maintenance manuals and illustrations, changed the service bulletin to avoid the need for simultaneous removal of both aileron cables, and began developing a new alert message to warn the crew if aileron cables were installed incorrectly. However, the GPI-AAF requested more specific design changes, which Embraer declined. At this point, I would like to reassure the reader of the fact that most airliners have control cables that cannot be accidentally swapped. The design of the E190 was uniquely poor in this regard, but it is not clear that Embraer's actions have eliminated the possibility of a similar incident happening again. Fortunately, however, that's something only pilots will have to worry about because the first flight after heavy maintenance is never conducted with passengers on board. OGMA revamped its quality control and inspections, hired an external company to improve its safety management system, and worked on enhancing its competency assessments. Well, that will be it for today's video. Share your thoughts in the comments below about any other airplane investigation you want to hear about. As always, don't forget to like our video if you liked what you saw. Subscribe to our channel to get instantly notified when we upload a new video. As always, see you in the next one.